27 seconds.
I have one. I just feel like
Yeah. Okay. All right. So we've done a few of these already. All right. We've done a few of these already. You've already been solving some differential equations. And probably if you saw this, what you probably did is you just went ahead and did, I'm going to raise my exponent by 1, that's x squared, divide out front by 2, which just gives you a 1, plus 5x, oops, 5x plus c. And then we'll have y equals right there. So you just integrated. What you probably would not write for that is that you had to multiply both sides by the dx to get rid of the dx on that side, which gives you dy equals 2x plus 5 dx. And then you integrated both sides. And so when you integrate dy, that is like integrating, it's like there's a 1 there, and you're integrating with respect to y. So if you integrate 1 with respect to y, you get y. And then you integrate this side with respect to x, which gives you this expression over here. So in a very, very, very basic way, we've already been solving differential equations. But very basic. So in order to solve a differential equation, you must separate the variables. And there are, like if you take differential equations, there are all kinds of other methods for solving things that are not separable. And I told you guys I didn't take that class, which I feel a little bit gypped on. So I don't even know all of them. But for this class, we will only solve separable differential equations. So you got to separate the x and y's. All the x's have to be on one side. All the y's have to be on the other. That is why technically, if I do this problem, I'm supposed to multiply both sides by dx, so the dx is over here. And then I integrate both sides, and I get y's on this side, x's on this side. Okay, so let's look at one that is going to actually require some separation and integration on both sides. So for this problem, I prefer dy dx notation. I don't even know if you can really get away with not using dy dx notation, but our book occasionally will give this notation where it's y prime. Y prime equals dy dx. So I'm going to write it this way, because to separate your variables, you need that to be a dy dx so that you can move stuff appropriately, so that you can separate the dy part from the dx part. So on these problems, always one of the first things you're going to have to do is multiply both sides by dx, because that dx cannot be in the denominator. You need the dy in the numerator on one side, you need the dx in the numerator on the other side. In general, I always try to put my y's on the left, x's on the right. Technically, it could be the other way, but you have to have your dy's and dx's have to be numerator. So what I've got right now is dy equals 2x over y times dx. I cannot solve that because if I did, I would have to integrate something over here with respect to x, but I have a y on that side. So how could I get rid of that y? Multiply by y. So you could have done it in the last step there if you wanted to. Multiplying by y, I'll cancel this out here. So what I end up with is y dy equals 2x dx. And so all the y's are on one side. I've got the dy with it, so that tells me what I'm integrating with respect to. All the x's are on the other side. The dx is with it. I'm just going to integrate both sides. Okay, so when I integrate y, I will get 1/2 y squared. I'm going to do this. I'm going to put plus c1. So c was subscript of 1. I'm going to show you why I'm doing that here in a second, and then why you don't even have to do that on the next problem. And over here, I will get just x squared plus c2. Now, I don't like having that C1 and C. Like, I don't like having C's on both sides. What is a C? It's a constant and it's unknown, right? So, like, if I did this, if I subtracted that C right there, I would have 1/2 y squared equals x squared plus C2 minus C1. So, C2 minus C1, those are just unknown constants, right? Which is just another unknown value, right? So we could say let just capital C equal this. So we could have 1/2 y squared equals x squared plus C. That way we don't have two C's on each side. In fact, you don't even have to write this. So in the next problem, I will show you that what we're going to do is we're just going to put the plus C on one side whenever we integrate. It is okay. They will assume you know what you're doing if you just put the plus C on one side that encompasses the plus C for both sides for both intervals there. So we don't, I did this to explain why we could put that all together and just put a plus C on one side, but we don't have to do that every time. You could, but you don't have to. So the way that they leave the answers on this, it just depends. Sometimes they will solve it for y. I doubt they would for this one because if you solve for y, you got to square root both sides and you need a plus or minus, so I don't think they would do that probably. They might move that x squared over to the other side. This is going to be like a hyperbola that you would have here. I'm just going to leave it like this for this problem. So this would be your solution. All right, so one thing we need to know for this is if our equations are separable. So sometimes our equations will be separable, other times they will not. So it's not asking you to solve these here, it's just asking you whether or not you can separate them. So, for example, if I was trying to separate here for my dy dt, one of the first things you're going to have to do every time is you're going to have to multiply by that dt, because you cannot solve a differential equation if the dy or the dt is in the denominator of the fraction. So that would give us dy equals, notice I put parentheses around this, they must be there. Okay? Can we get rid of that y? So these parentheses are important. Like I would have to distribute this dt. Right, so I'd have dy equals y dt plus t dt. So I could like subtract that y over to the other side, but if I do, the dt has to go with it. And so like if I tried that, this is going to be a dead end, but if I tried that, it'd look like this. Well, if I wanted to try to get rid of the dt, I would have to divide by that dt. But if I divide by dt, I'd have to divide this by dt. Right? So it'd get rid of this dt, but there would still be a dt on this side. So I'm not going to be able to separate these. There's not any way that that's going to work. So this one would be a no. In general, most of the time when you have like a plus or minus sign between your variables, it's going to be an issue. Okay, for B, we need to know if that's separable. So always on these, just go ahead and do the dt over here. So we got dy equals ty over t plus 1 dt. So I need to try to get rid of that y right there. That's my issue. Can I? What? Divide by y? Because if I divide by y right here, you know, that would be in parentheses. These two things are multiplied. These would cancel. I could divide by y over here as well. And so that would give me dy over y, or you could think of it as 1 over y, dy equals t over t plus 1 dt. All the y's are on one side, all the t's are on the other. Both dy and dt are still in the numerator position. They're not in the denominator, so this one is a yes. Those are separable. It will not. Dy is like a separate variable. So it's not like it's d times y. It's a whole separate variable itself. So you could call it like k or something, sort of. It's a whole separate variable, so the y's don't cancel there. That's a good question. Same thing with t's, of course. All right, C. I've been using these notes for several years. The first 2 or 3 years that I taught this, I said no for C, and I was wrong. C will separate. I want you to see if you can separate them. Yes, so I think Connor's got it there. All right, so the key to separating this one, and don't worry, this will not be something you've got to do a lot of because I used to teach this. This was a no. But if I have something like x squared times x to the third, I would take those exponents and add them together. So if I've got e to the t plus y, I can write it like this, e to the t times e to the y. Yeah, so that's the key to being able to break these apart. And then if you do the dt on both sides, that gives you dy equals e to the t, e to the y, dt. You need that e to the y to go away, so you can divide by e to the y on both sides. So you got, I'd probably do e to the negative y, dy equals e to the t, dt. So that one is a yes, it can separate, but it's not very easy. Well, it's really not that difficult once you see that one little trick, but that trick is not necessarily so widely no. So a lot of you trying to like use a natural log to get rid of the e, but the problem with that is you end up with a t plus y, and you get in a situation like A where you can't separate those because of that plus sign there. So this gets rid of the plus sign, and then you can separate there. So separating the variables is a big part of the battle whenever you are solving differential equations. Because if you do not separate your variables, then you're not going to be able to get the problem right. Not every year, but most years there is a differential equation problem. And like we did some of the parts of it, it might have like a slope field and ask you to do a few points on the slope field. It might ask you something about a tangent line or something like that. But then the last part of those problems is almost always to solve a differential equation. And to solve that differential equation, it's usually worth 4 or 5 points for that section. It's a big, heavily weighted section of the FRQ. And if you do not separate your variables, you get 0 points for it. You will not get any points if you don't separate your variables. If you separate your variables incorrectly and then solve from there, you can get some points. But if you don't even try to separate, if you try to take the integral without separating anything, you get nothing on those. So it's a big hit. So separating is really important. So let's look at 4. All right, so must separate first. So we're going to multiply both sides by dt. So I've got dy equals y squared e to the negative t dt. I need to get rid of this y right here. So I'm going to divide both sides by y squared. And so you can write that however you would like. I am going to go negative exponents on that. I'm going to make that y to the negative 2 dy equals e to the negative t dt. So this is key. You must separate those variables. If you do not separate them, you get 0 points on that problem. There's no way you'll ever solve it right if you can't separate the variables. Once the variables are separated, you want to integrate both sides. And you want to integrate both sides at the same time. So if you end up with like a u-du substitution sort of thing, you kind of do right here, but I think it's one we can probably do without actually changing it to u right here. Then you need to make sure that you integrate like all at one time. So this is on the left-hand side, this is just a power rule integral. So you're going to increase your exponent by 1. You get y to the negative 1 power. You divide out front by that negative 1, which is just going to give you a negative there. We would put a plus c, but as I showed you on the last one, it is okay to combine the plus c's. So I'm just going to make the plus c go over here on the right-hand side. For the other side, this is like a very minor u-du substitution because your u would be your exponent, which is negative t, and your du would be negative dt. So you would need a negative with that dt and a negative on the outside. And so I am going to integrate that. I'm not even going to like write it with the u's in. E to the negative t is going to be e to the negative t, but you'll have that negative that we had to add in out front. And then we'll put a plus c. Now, at this point, you have solved the differential equation. Sometimes it wants that to be solved for y. Sometimes it's like they don't really care. So, one thing I would probably do for this one, because you got a negative right here and a negative right here, it would be okay just to divide everything by -1. And so you got y to the -1 equals e to the -t plus c. Notice I didn't change that to a minus c. Why not? It's an unknown constant, so it doesn't really matter whether it's positive or negative, because it's just going to, like, since we don't know it, it doesn't matter if it's positive or negative, because we could just make the c positive or negative to compensate, right? So when you do things to the c, you don't really have to do things to the c. So this would be, this is 1 over y equals e to the -t plus c. If they wanted this solved for y, and they may not, it just depends on how, like, answer choices for this, or if the problem tells you to. We'll see somewhere the problem tells us to. I could multiply both sides by y. So I get 1 equals y times e to the -t plus c, and divide by e to the -t plus c. So y would equal 1 over e to the -t plus c. So if they asked you to solve for y, this is what you would get. If they don't, it would be perfectly fine to leave your answer right here. It depends on how it is worded. Whenever we get to doing some of these FRQs, I will show you. There will be some times where it will say, like, there's a wording that they'll use that means you have to solve for y. So it just depends on how they word the problem. But a lot of times they will ask you to solve for y on this. I don't think so. Unless it is a weird problem where they don't use, like, x's and y's, they might have c's and t's. You typically are going to solve for the y. Yeah, the last one, or this one here, we did not solve for y. So the main reason I didn't make a solve for y is because if you do, you end up with like a plus. You have to square root both sides and you get a plus or minus. So you might, like, if they did ask you to solve for y, you'd multiply both sides by 2. Yeah, so 2x squared. Again, you can just do a plus c. You don't have to do 2c. You would square root both sides. So y would equal plus or minus the square root of 2x squared plus c. And then when we get to specific solutions, like, you would probably have to pick one of those, but that we won't see till tomorrow. Right.
But then you have to multiply the whole thing by 2. So but if you do it like that, then it's just saying that you're multiplying x squared.
Right. So you're multiplying 2c right here. So let's say c is, like, supposed to be 8. Like, let's say in the answer, let's say the answer is supposed to be plus or minus 2x squared plus 8. So we'll do specific solutions tomorrow where we are going to actually find the value for the c. So it really doesn't matter whether you have a c there or a 2c. So, like, if you know the answer ends up being 8, if you have a 2c, well, then c ends up being 4, but when you plug it back in, you still get 8. Or if you have a c, you'll just get 8 for that whenever you solve it. So, like, 2 times c is still just an unknown answer. Like, if it was supposed to be 8, then 2c, we'll see just 4 instead to compensate for that 2. So you could distribute it. It's not going to hurt anything, but you don't have to for that. As long as you do all the parts correctly, it's fine. Yeah. So if you put a 2c, it'd be fine. But you don't have to. All right. Okay. Let's do this next one. All right. That y prime, I'm going to change it to a dy dx. So 1 plus x squared dy dx. And I am also going to move my 3xy over to the other side of the equal sign. So I got negative 3xy. All right, so I always need to multiply by that dx to get rid of it. Okay, what do you guys think? What do I need to do? I got this 1 plus x squared over here. It can't be over here. I need to divide it off. And basically to separate, other than like here moving that 3x to the other side, it's mostly going to be either multiplying or dividing. You're not going to add or subtract very often because if so, it's not differentiable. So I got 1 plus x squared ends up over here. All right, so that looks better, but I still have this y right here. It can't be here. So we're separating. So that y, I could divide by that y. So if I divide by the y, it'll cancel it here. Divide by the y here. So I've got 1 over y dy, or you could write it as dy over y, equals negative 3x over 1 plus x squared dx. Okay, I love these problems because it puts so much together. You got all this separating. Now you got to integrate both sides, which means you have to know how to integrate basically 2 different problems. So what I would suggest here, the left side is pretty simple to integrate. The left side is just natural log of y. What are we going to have to do on the right side? U du. Grace sounded so disappointed in the u du. She's like, not again. We've got to do a u du over here. I would not integrate the left-hand side yet. Because if you are going to share a plus c, and you want to because it will make life easier if you only have 1 plus c, you need to integrate at the same time. So like if you integrate this left-hand side right now, but you don't integrate the right-hand side until a couple steps down, then technically you should have had a plus c right here. So I just leave it as an integral until I'm ready to integrate both sides. So u for this one is going to have to be 1 plus x squared. Du is going to be 2x dx. So what I'm going to do is I'm going to take that negative 3 and I'm just going to pull him out front because he's kind of in my way. I'm going to replace him with a 2. We need to multiply that right there by 2, which means I've also got to multiply out front by the 1/2. And so I got 1 over y dy. Notice I'm not integrating yet because I want to share the plus c. I'm going to have negative 3/2. And this is going to be this part right here. This part right here is my u. This stuff right here is my du. So I have 1 over u du. Okay here? Alright, so we are ready to integrate both sides now. So on the left-hand side, I'm going to get natural log of the absolute value of y. On the right-hand side, I'm going to get negative 3/2 natural log of the absolute value of u. And then I'm going to put that plus c on the end that, I'm going to put that plus c on the end that covers both of my integrals there. So it covers the integral on the left and the right. And we want to put the u back in. If you went ahead and did that in that step, that's fine. I have waited. So I've got -3/2 natural log of x, 1 plus x squared. Plus c. If you had already done this problem, and you are maybe moving on, you need to watch the end of this because I doubt you are going to do this next part that I'm getting ready to do. I did change this to a 1 plus x squared just with parentheses. Why can I do that? X squared is always positive, so 1 plus x squared is always positive. So I don't have to have absolute value bars there. If you leave them, it's probably okay, but a lot of times you'll see them take them out if they're unnecessary. So we need, let's say that it asks us to solve this for y, because a lot of times it will ask you to solve these for y. So if we need to solve this for y, then I need to get rid of this natural log by doing e to the power. But if we're thinking ahead a little bit, e to the power over here will get rid of this natural log. It will not get rid of this natural log because of this -3/2. Because it has to be the e raised to the natural log. Okay? So when we have a natural log, we can take this and bring it in as an exponent. So I'm going to do that first because it's going to make it a lot cleaner whenever I solve this for y. So I'm going to have natural log of the absolute value of y equals natural log of 1 plus x squared to the -3/2 plus c. Okay, then when I raise both sides to be powers of e, this will cancel, but I've got absolute value of y equals, all right, so what I've got right here is e to the natural log of 1 plus x squared to the -3/2 plus c. The c is not inside of that natural log. So the c makes it where the e and the natural log are not going to cancel out right away. Okay, if the c was on the inside of the natural log, then the e and the natural log could cancel, but it is not, and you can't put it there. There's no rule that'll let you put it there. So what we're going to have to do is basically use that rule that we used whenever we were separating that exponential problem. If I have x squared times x to the third, that gives me x to the 2 plus 3, right? So I've got e to something added to something else. Okay? So I've got absolute value of y equals, I can write it this way, e to the natural log of 1 plus x squared to the -3/2 times e to the capital C. Now, this c and this natural log can cancel. Also, let's discuss something here. E to the capital C is e to an unknown constant. So, Allie, if you're having trouble with the 2c, this one's even more disturbing, but you're going to need to do it. E to the unknown constant is still going to be an unknown constant. So e to the capital C can just be a capital C. If you want, you could even you could put like a 1 right here, like if it makes you feel better, and then say let e to the C1 equal C. But as far as I know, they accept it if you just take that e to the C and turn it into a big C. So we get absolute value of y equals, we're going to write that big C, since we're replacing this with a big C. I'm going to write it first, and then I'll have 1 plus x squared negative 3/2. And most of the time, they will drop these absolute value bars, because to get rid of those absolute value bars, you could compensate by putting a plus or minus over here. But a plus or minus is not really necessary with a C, because C is an unknown constant that could be positive or negative anyway. So a lot of times we'll just see them drop those absolute value bars and leave it like this. Yes? Yeah, because that negative 3/2 is on the outside of the natural log. So you cannot distribute it to the inside because it's not multiplied by just the 1 plus x squared. It's multiplied by that natural log. So the properties of exponents tell us, and see the issue is, like, if we try to do e to that power, that negative 3/2 power, like, isn't going to work because it's the buffer between those. You have to have e raised just to a natural log. So if we pull it in as an exponent, which the properties of logs tell us we can do, then you got an e and a natural log right next to each other so they can cancel. Right, properties of logs from like pre-calc. Yeah, yeah. So whatever is out front. So if I have something like 2 log of x plus 3, I could pull that in, and it would be x plus 3 squared. So if you have a coefficient out there, you can pull it in as a coefficient. Yeah. I mean, you don't use them every day, but they show up. They're basically this: if you've got log of x plus log, log of x plus log of y, you can write it as log xy. Log of x minus log of y is going to be log of x over y. And then you got your power rule, where if we've got like a log of x, it is log of x to the a power. Those are the ones that you'll need to know. The other one would be like being able to drop logs on both sides there. So yeah, it's a good idea to have those in your memory. We won't use them every day, but we will use them here and there. Okay. All right, so your assignment is page 382, 1 through 8. Let me look at what they do with the answers. Let's see. 382. I will tell you that they solve for y on the answers for all of them except 4, 5, and 6. So try to solve for y on the answer. Except 4, 5, and 6. They do not solve for y on number 5 and number 6. So constants don't have to go on a specific side. So what you can do on that one, like to separate, dy over dx will equal y plus 3. You'll have to multiply by dx. So keep this whole thing right there together. It's y plus x. So you can divide by y plus 3. So you'll get dy over y plus 3. And then you'll just have a dx over here. Constants are okay. So that plus 3 can go on either side because it does not have a variable. So if there was a way to separate it where you could leave it over there with the dx, you could, but there's not, because it would have to, like, you'd have to distribute the dx, and then it would have a dx with the y, which would not be good. So you have to take the y over to this side with that. The example that we did had like a y plus a t, and we couldn't separate those, and we couldn't do anything with it. But if it is a constant, it can go on either side as long as it doesn't have an x or a y with it. So, and that was number 3.